This is a walkthrough of problem 1 on exam 1 of module 3 from the book Problem Solving Guide for Mechanics and Thermodynamics. Problem 1. A few seconds after liftoff, an 8,000 kilogram rocket is moving upwards at 30 meters per second and speeding up at a rate of 4 meters per second each second. What is the upward thrust force on the rocket from the engine? Ignore air drag. Let's start with a good diagram. There's our rocket. What are the forces on the rocket? Well, we're going to assume the rocket is still close to the Earth, so gravity is still pulling downward on it. It says a few seconds after liftoff. So gravity is downward, mg. The thrust is upward, that's why it's accelerating upward. And we should draw the thrust force bigger because the rocket is accelerating upward. It's overcoming gravity. Those are the forces. They're easy to add because they're in the same direction, parallel, they're anti-parallel. Sum of the forces is ma. We only have y components here. The net force is F thrust minus F gravity, right? That's the net force, so that's ma. Gravity is mg. We substitute in mg for F gravity, and now we can plug in the mass and the gravitational field strength. So the weight, the force of gravity, 80,000 newtons downward, and the result of those two forces is 32,000 newtons. This is not a force on the rocket. This 32,000 is the result of the two forces on the rocket. So now we just have to solve for F thrust. Putting the 80,000 on the other side, we get 112,000 newtons, and that's the answer to the question. Note that the speed of 30 meters per second is not needed for anything. We have forces and accelerations. We don't put speeds in there anywhere. That's problem 1. We are off to a good start.